Alright guys, the warm-up, go ahead and try this. This is a really challenging problem, but when you put me back on resume, I'm going to fly through this because it's going to take me time and I don't want to lose time that I need on the lesson. Okay? Alright, first thing you need to understand is that division, anytime you have a fraction, no matter how complicated it is, you are going to have to change it to multiplication and take the reciprocal of the second fraction. So first flip the second fraction and change it to multiplication. This is probably one of the hardest state exam questions I've seen on an Algebra 1. You can't just cancel x squareds and x's in here. Anytime you have a trinomial or a binomial, you can't take parts of it. It has to be the whole binomial with another exact same binomial or trinomial, etc. So the only other way you can handle this is if you factor each one of the numerators and denominators. If you factor the numerator up here, I'm only looking at this one, it would be x, x, plus, plus, and the 2 times the 7 is going to give me the 9. That's factoring this numerator. If you factor the denominator right here, that's difference of perfect squares. So you're going to get x plus 7 and x minus 7. Factoring the numerator right here, you're going to get, x, x, you're going to need a plus and a minus to get a negative 56, and 7 times 8, making the 8 the positive, is going to give you that positive 1 for your middle term. The denominator, you take out the GCF, which is 3 times x plus 2, and now once you get to this point, now you can actually cross off as long as you're simplifying the same exact binomial with the same exact binomial. The denominator cancels with a numerator, x plus 7. X plus 2 up here can cancel with the x plus 2 down here. This x minus 7 can cancel with this one. And nothing else can cancel, so we end up with x plus 8 divided by 3. Final answer. Okay? Alright, let's go on to the lesson, which is factoring to solve quadratic equations. I'm sorry you can't see the top, but it is factoring to solve quadratic equations. The zero product property tells you that when you multiply anything by 0, your answer is 0, even if it's a binomial. So if you look at this example below, they've factored it. You have a binomial times a binomial equals 0, which means really, in order for me to multiply anything by another number to get 0, this one would have to equal 0, or this one would have to equal 0, or they both have to equal 0. But regardless, one or both of them are going to have to come up to 0. So what they tell you to do is to take the whole binomial, set that equal to 0, and set the other binomial and set that equal to 0. Solving each one of these, you're going to end up with an answer of -3 and an answer of 8. So those are going to be the possible answers, which we call roots. Now don't forget, you got to make sure you check these answers to see if they work. This problem is simple because, or simpler, because they've already factored it for us. We're now going to get into ones where we have to factor them ourselves and then break them apart and set them equal to 0. Let's first go ahead and write down the process, which is right here, solving quadratic equations by factoring. Please put me on pause, copy this down, and then I'm going to go on to the examples. So please put me on pause right now. Alright, so you've copied that strategy down. Let's go ahead and look at this question. I'm going to rewrite it. X squared plus 8x plus 15 is equal to 0. First thing you want to make sure, as you wrote down in your strategy, you've set it equal to 0. Sometimes they'll scramble it up on you. Also make sure it's in standard order, which means highest exponent first. Now we're going to go ahead and factor. Is there a GCF? No. Is it difference of perfect squares? No, that would be a binomial. So we're going to go ahead and do regular factoring like we have done. X times x would be my first term. If I go to the last term, it's a plus. What times what is a positive? Same signs, and I'm going to have to pick the plus plus. Remember, if I'm going too fast for you, please put me on pause. Listing all the factors of 15, you get 1 and 15 and 3 and 5. 3 and the 5 are the two that are going to add up to get me to the middle term, and it doesn't matter where I put them because everything inside is the same. So we have x plus 3 equals 0 and x plus 5 equals 0. Once we separate them, we fully factored and we separate them just like I showed you 2 screens ago, you're going to solve each one to figure out what the possible answers, or better yet, roots are. So the first possible root is negative 3, and the second possible root is negative 5. Now, here's the part that we find a little bit of a nuisance, but we have to go ahead and check it. Is negative 3 squared plus 8 times negative 3 plus 15 equal to 0? Negative 3 squared is 9. 8 times negative 3 is negative 24. Plus 15 is equal to 0. 9 minus 24 is negative 15. Plus 15 equals 0, and 0 equals 0. That checks, so I can confirm that that's a correct answer and not what we call an extraneous root. Checking negative 5 squared plus 8 times negative 5 plus 15 equals 0 would give me 25, minus 40 plus 15 equals 0. That would give me negative 15 plus 15 equals 0, and 0 equals 0. So that actually checks. So we know negative 5 and negative 3 are roots of the answer. If you ever graphed it, which you don't have to, but don't forget, negative 3 would be here, negative 5 would be here. It's a leading coefficient of 1, so the parabola would look something like this. I don't know where the vertex hits, but we're not going to worry about it because we're not graphing. All right, let's try this one. 4x squared minus 21x equals 18. This one's not set equal to 0, so we're going to have to set it equal to 0 by subtracting 18 first. Remember, it's got to be set equal to 0 before you guys, let's see, what is that? Negative 39x. Before you guys, whoops, that's not right, Ms. Ramasher. It's not like terms, my bad. Minus 18, I'm going too fast. You have to set it equal to 0 before you guys actually factor. There is no GCF in this one, so I'm going to have to deal with a leading coefficient of 4, which is a little bit frustrating because I'm going to do a little guessing and checking that's going to happen here. I'm going to try 4x and 1x. I know I got to have a plus and minus. I have no idea where they go. We're going to be patient. 1 and 18, 2 and 9, 3 and 6. Let's try the 2 and the 9. If I multiply these, I get negative 36, and positive 2x. That's not going to work. All right, let's try 2 here and 9 here. That would give me 9 and negative 8. That's not working. All right, what about the 3 and the 6? 3 and the 6. That would be 3 and negative 24. Ooh, I like that one. 3x and negative 24x, am I right? Would give me negative 21. There it is. That's the one that works. So once you factor it, now you separate them and set each equal to 0. So you get 4x plus 3 equals 0 and x minus 6 equals 0. Solve each one individually, and we get 4x equals negative 3, negative 3/4. When you guys do the check on this one, I would just go ahead and put in negative 0.75. That would be easier to do the check as the decimal version. And x equals 6. I'm not going to do the checks now, but make sure you guys go ahead and do the checks, and I'll check to see if you have that done when I look at it. Okay, so I can keep going and not miss out on time. I want to get to this one. This one says you are constructing a frame for the rectangular photo shown. You want the frame to be the same width all the way around and the total area of the frame to be 315 inches squared. What should the outer dimensions of the frame be? So they want to know, what does this have to be out here? This and this. Well, we know that the area is the length times the width. Well, let's see. I know that if from here to here is 11, which I can see right here, then this is x and this is x. This would be 2x plus 11. Whereas from the length direction, I know from here to here is 17 plus another x here and another x here. That would be 2x plus 17 would be the length. So I know if you multiply the length times the width, I will end up with the area. So there's my width, here is my length, and I'm going to set it equal to the area they told me, which is 315. This is FOIL, so let's go ahead and do first, which would be 4x squared. Outers would be 34x. Inners would be 22x. And last, I have no idea, would be 11 times 17 is 187. Is equal to 315. So if you add these together, we get 4x squared plus 56x plus 187 equals 315. This is a quadratic because of the squared, so we're going to have to set this equal to 0. That's going to give me 4x squared plus 56x minus, now we have to go, let's see, 187, and you're going to subtract 315. That gives me negative 128 equals 0. Now, there is a GCF, I believe. 4, we can take a 4 out. 4 times x squared plus 14x minus 32 equals 0. That's good news to take that out, because now when we go to factor this, we're going to end up with x times x plus and minus to get my negative, and 32, let's see, 1 times 32, 2 times 16, 4 times 8, and we need it to add up to 14 or subtract off to 14. That would be the 2 and the 16 because I have opposite signs. I need the 14 to be a positive. 16 goes here, 2 goes here. Set each equal of these to 0. Even the monomial, that's not true, so we just say it's not equal to. Set the first binomial equal to 0 and set the second binomial equal to 0. Subtract 16 from both sides. And we end up with 2 answers. Now, interesting, we have to use common sense right now. Remember, x represented the width of the frame. It cannot be negative 16. So we're not going to erase, we're just going to cross it off. So that means the width is going to be 2 times 2 plus 11, which is 4 plus 11, which is 15. And this one is going to be 2 times 2, which is 4, plus 17, which is 21. Let's make sure that checks. Does 15 times 21, does that equal the area which they told us, which is 315? And it does. So that means, therefore, these 2 answers, which I just circled, are the correct answers in inches. Okay, and that takes care of it, and I'm almost done with time, so here we go.